The next method to solve systems of linear equations will be the method called substitution. In the last lesson, we graphed it to see the solution. And remember, we either had 1 point, no solution, or the lines coincided and all the points on the line were the solutions. Instead of graphing, we're going to use algebra. And again, it's called the substitution method. So we have several steps, as you can see here. We're going to choose one of the equations and solve for one of the variables. And you really want to try to pick a variable with a coefficient or 1 or -1. That way you won't have to deal with a lot of fractions. Then we're going to substitute, that's why it's called substitute, this expression into the other equation. Then we're going to solve the resulting equation because it should now only have one variable. Then we're going to take that solution and again substitute it into the expression obtained back in step 1. And then our answer, remember, is an ordered pair. Remember that it's still two lines. Remember, if we were to graph them, they would intersect in 1 point possibly. So let's follow these steps. And we're going to start out really easy. We're going to solve by the substitution method. So the first step says to choose one of the equations and solve for one of the variables. Well, if we look here, that one is already solved for. In fact, we know exactly what y equals to. They've done half the work for us. So we're going to substitute this expression into the other equation, meaning I'm going to substitute in 5 for y. And I'm going to solve. So I'm going to add 5 to both sides, and I'm going to divide by 4, and I'm going to reduce that fraction. Now, since I know that y is 5 and I now have x, I can kind of skip to step 5 because this one was so easy. I got to skip a few things, and my ordered pair would be 1/2 5. This is exactly the reason why graphing is not the best, because it would be very difficult to read from a graph 1/2 and 5. That graph paper would have to be, I don't know, it would just have to be so accurate. The algebra is just easier. Okay, number 2. Again, we're looking at this, and this equation is already solved for y. It doesn't tell us that y equals to a number, but it tells us that y is equal to 8x minus 7. So we're going to substitute this expression into the other equation. Again, 8x minus 7 goes in place of y. Use those parentheses. Now my equation has just one variable, so I'm going to solve by distributing. I'm going to collect like terms. Let's see. Subtract 14 from both sides. Keep going. Oops, I left out my x. Then I'm going to divide by -13. And 0 divided by a number is 0. Am I done? No, that was just step 3. Now I have to go to step 4. Take this solution and substitute it into the expression obtained in step 1. Well, step 1 was that, getting the variable by itself. So I know y is 8 times 0 minus 7 because I now know x is 0. So y equals 0 minus 7. Now I have an x coordinate and a y. X, y. There's my ordered pair. How could I check my answer? I can substitute in 0 for x and -7 for y. See if it works in that equation. But I also have to substitute in 0 for x there and -7 there and see if it works in that equation as well. It has to work in both. The next two examples, we're going to do a little bit more work. So go back and read the notes. It says pick an equation and solve for a variable, and try to pick one that has a 1 in front. So I don't think I want to use this equation, but this one, either one would be easy to solve for because they have a 1. So I'm going to choose this one, and I'm going to choose to solve for x. So if I have x plus y equals -6, I can move the y to the other side by subtracting it. So step 1 says to choose an equation and solve for a variable. I did that. Step 2 says to take this expression and substitute it back into the other equation. So since I've solved for x, I'm going to substitute it in for x into the other equation. Now I have an equation with just one variable. I'm going to solve. I'm going to collect like terms. Am I done? No. Step 3 says go back up here and put in your answer. So I have x equals -6 minus y, and y is 1. So x equals -7. Now I have solved that. I'm writing my answer as an ordered pair. X and then y. Again, you could check it in both of those, letting x be -7 and y be +1, and you would get true statements. Okay, number 4. Step 1. Choose an equation, choose a variable, preferably one with a 1 or a -1. Well, the only one I see that has a 1 or a -1 is that one. So I'm going to choose this equation, and I'm going to solve for x. Now you can choose the other ones. You would just have a lot of fractions. Alright, so I have x minus 8y equals to 1. Move the 8y to the other side. So step 2 says to take this expression, substitute it back into the other equation for whatever variable you solve for. Again, I have solved for x. So I'm going to replace x with 1 plus 8y. Again, checking, I have one equation with one variable. Subtracting 7 from both sides, I get a -15. And I can reduce that to -1/4. Not done. Go back to that step. And that's going to tell me x equals 1 plus 8, and what's y? -1/4. So let's see, 4 goes into 8 2 times, so that's 1 plus, that's a -2. So again, my answer, x is -1 and y is -1/4. Unless our graph would be really, really, really accurate, we would never get that answer, and that's why we need algebra. One more. So again, step 1 says look at the equations, choose an equation, choose a variable that has a 1 or a -1. Well, again, my only choice that would be easy would be that one. And again, I'm going to solve for x. So let's see, I would have to move the y, the 2y to the other side by subtracting it, but I got to still get x by itself. So I'm going to divide everything by -1. Then I substitute this in to the other equation. You could have solved for y. I know my example's kind of all solving for x, but you choose the one that's the most convenient. So we're going to have, let's see, 4 times not x, but negative 9 plus 2y. Distribute. So I'm going to add 36 to both sides. Oh, that kind of came out nice, huh? So y is 2. Not done. Go back to where you started and substitute in your answer. Do the arithmetic. And my ordered pair is x and then y. Again, check them, see if they work in both equations. Now we have some special solutions. If both variables are eliminated when you are solving a system, meaning your variables poof, go away like magic, there's no solution when the resulting statement is false and it's inconsistent. Remember that? What does that mean? It means that they were parallel lines. They didn't cross. There's infinitely many solutions when the resulting statement is true or they are dependent. They were the same line. Instead of maybe using infinitely many solutions, I said all points on the lines coincided. All of those mean the same thing. So let's look at number 6. It says, choose a variable, choose an equation, choose a variable that has a 1 or a negative 1. Again, that's just to avoid fractions. So I'm going to choose this one, and I'm going to solve for x. So move the 2y to the other side. Then I substitute that back into my other equation. So I have negative 2, and in place of x, I have that. Distribute. Oops, negative times negative is plus. And look at what happens when I start collecting like terms. That is 0. What I have left is negative 10 equals to 7. All my variables went away. They were eliminated. I'm not done. Is this true or is this false? Does negative 10 equal to 7? No. That's false. Still not done. Not answered the question. So I'm asked what is the solution to that system? At this point, you could say no solution. Because the lines are parallel, you could stop there. But remember, that also means inconsistent. Let's look at number 7. Step 1, look at the equations. Any variable has a 1 or a negative 1. Yes, it does. This time I'm going to solve for y, because to me that would be the easiest. So taking this 3x to the other side. Now I'm substituting this in for y into the other equation. So 2 times what is y? Working that out. Collecting like terms, variables poof disappear. Poof disappear. Not done. Is this true or is this false? This is true. What did that mean? It means they were the same line to begin with, so we could put dependent. We could also put infinitely many solutions, or like I think on the other lesson, I put all points on the line. That is the substitution method, step by step.